Hello and welcome to our video on parabolas and introduction to parabolas. Going back to some of our previous work, you will remember that a linear equation has a highest power of x equal to 1. So you might remember the general form of a linear equation. Looks like this: y equals mx plus c, and the x there's no power written there, no number, which means it's a power of 1. Other linear equations with numbers in them could look like this: 2x plus 3, with the highest power of x is 1 there as well. Or it could just look like this: y equals 5x. The highest power of x is 1 there as well. Linear equations, when we graph these types of equations, they form a straight line. That's why they're called linear. So a reminder, when we graph them, they look something like that. Now I want to go back to when we looked at quadratic equations earlier, which have the highest power of x equal to 2. So an example of a quadratic equation could be y equals x squared plus 4x plus 3. So this has got an x to the power 1 term in it, but there is an x squared term. So the highest power of x is 2. So this one is a quadratic equation. You could have y equals just 3x squared. Highest power of x is 2. Or you could have it looking in a slightly different form. You might remember this one is called Factorized Form, where if you expanded this, you would get an x squared term, so the highest power of x would still be 2. Or you might have something that looks like this. So all of these are quadratic equations. All of these ones are linear equations. A parabola is the name for the shape of the graph that we draw from a quadratic equation. This is what a parabola looks like. And I'd like to point out a few different features. This is just one example of a parabola, but I'll use this one to show you the different features. So when we had our linear graph, we only had one x-intercept and one y-intercept. Might draw a better version of that. There we go. One x-intercept and one y-intercept. A parabola is a curve that goes down and comes up again. And it can have two x-intercepts. So x-intercepts are where it crosses the x-axis. It will have one y-intercept somewhere. I've labelled the origin for you, which is at 0, 0. So you might find it useful to use that term to describe this point here. A parabola has a turning point right at the bottom of the graph. For this graph, it's a minimum turning point because all the values go all the way down until they get to the turning point, and it turns around and goes up again. So this is the minimum value. There is no maximum for this parabola because they keep going on infinitely high. So just like our straight lines kept going all the way to the right hand side and all the way to the left hand side, parabolas keep on going up and up higher. But they'll never go lower than this this parabola will never go lower than this minimum value here. I've also put in green, it might be a bit tricky to see, a dotted line there that shows you the axis of symmetry. Now parabolas are always symmetrical, perfectly symmetrical, and their axis of symmetry goes straight through the turning point. So you can use that information if you have one of the x-intercepts and you want to find the other one. You can reflect it over and you can know that you'll find the x-intercept on the other side. Okay, when you are graphing parabolas, you need to make sure that you show the following things. And I'm going to put them in green. You don't need to put any of these labels on in red, usually. But you need to label the things that are listed down here. First one says arrows on axes, which you need to do for every graph. So there's your arrows. You need to label your axes, X and Y. You need to draw a smooth curve joining the points. Now I say that because some people get a bit overexcited about drawing parabolas, and they might draw me something that looks like this, which is a V shape. And they haven't got the little curve happening at the bottom there very well. See how this one curves? If you draw this graph, it's actually not a parabola. It's a different graph. It's called a modulus graph. And we'll learn about those later on. But you need to make sure that your parabola has a gentle, smooth curve going all the way through. So I'll put a cross through that so you know not to do it. You need to extend your graph to the edges of the graph. So the blue line that I've drawn here, again, I'm putting this in because some people draw me these mini little parabolas that look like this. So you need to make sure that yours goes all the way to the top and to the edges of the graph. So I'll put another cross through that. Your graph needs to be symmetrical around the turning point, which I've listed here. We often say TP for turning point. You will need to label your x-axis intercepts, and you label them by writing the coordinates. So to write this one, I find a spot close by that doesn't have other things written in it. And that would be -3, 0. So I write the coordinate point. And the other one here can be -1, 0, 0. There we go. You need to label the y-axis intercept, which is here. Same thing with your coordinates. 0, 3. You need to label the turning point. So this one here is a minimum, and you label it with, normally you'd put this point closer up here. I just don't have room at the moment, so I'm drawing an arrow. Label it with coordinates, -2, -1. And you need to label the equation of the graph. So to write the equation of the graph, you can find a spot that doesn't have any clutter. Usually at the top right hand side or the top left hand side needs to be next to where the graph that you've drawn is. This is important particularly if you've got more than one graph on the same set of axes. So you can say label which graph is which, but it's important to do it for every graph that you draw. So I'm going to label this one as y equals x squared plus 4x plus 3. A few basic graphs for you to have a look at, just like the one we drew in the first example. This one here is what we call a positive parabola, and the equation looks like this. Y equals x squared. It's our most basic parabola. It goes through the origin. The turning point is at the origin. The axis of symmetry is through x equals 0. The minimum is at the origin. The x-intercepts are at the origin. The y-intercepts are at the origin. Everything is happening at the origin. moving on to our second basic graph, and this one has the equation y equals negative x squared. And you'll need to memorize which ones, just like when we when we memorized the linear graphs, to know which one had a positive gradient and which one had a negative gradient. You need to remember which one of these is positive and which one is negative. But lots of people like to remember that this one looks like a happy face, and this one is a y equals x squared positive, and this one looks like a sad face and it's negative, y equals negative x squared. So you can find your own way to remember that. Lastly, I just want to explain about different forms you can have for an equation. So far all the equations I've given you are in y equals form. For example, y equals x squared plus 4x plus 1. You can also write your equation in f bracket x equals form. So I'm just writing out the same equation as up here. Instead of y, I'm going to write f bracket x. When you read this new way of showing an equation, you say f of x, f of x. We tend to say it a bit fast like that, f of x. F of x equals x squared plus 4x plus 1. And this f of x means the function, the f stands for function, with x as its variable. So it's telling you that this side of the equation will have x's in it. If you had one with a's in it, it would be f of a equals a squared plus 4a plus 1. So that's just rewriting this one with a's instead of x's. Y and f of x are completely interchangeable. They mean the exact same thing. So you can use either one, and you'll start to see some of your notes are written out using f of x form, and some of them are using y equals form. The only thing you need to be aware of is when you're labeling your graph, you label this axis as x, but if your graph is an f of x graph, you need to put f of x for this axis instead of y. Thanks for watching our video today.